Hello, everyone. Welcome once again. So today we are on chapter 4, that is discrete random variables. Okay, so with section 4.1, we will talk about random variables, what we mean by a random variable, and we'll get to know discrete random variables and that of what the continuous random variables. But before then, we have to know what we mean by a random variable. So a random variable actually is a function that assigns real numbers to events or elements in the sample space. So here we have it to be a numerical quantity that is generated by a random experiment. So when you have a random variable, we have it in two parts. We have the discrete and that of the continuous. So for you to know that this kind of random variable is discrete, it implies that that random variable takes finite or countable number of what possible values. But when it is continuous, it implies that it takes values in a whole what interval of what numbers, that is infinity. So that will help you know that indeed such a random variable is continuous or is a discrete. Okay, so there are some examples here for us to determine that this kind of random variables are discrete or what continuous. So we have A to be the number of passengers in a car. We know that the number of passengers we take an exact number. It could be 0, 1, 2, or 3. So this is a discrete random variable. We apply the same analogy. So you realize that the number of clerical errors in a Word document, that if you have 0, 1, 2, this is also a discrete. And the weight of a baby giraffe could take some kind of what decimals in it. And this is what a continuous random variable. And note, the height of an elephant to the nearest inch, this implies that we've rounded it to what? The whole number. So this is a discrete random variable. And the time is actually a continuous variable. So we have it to be a continuous random variable. And the number of accident-free days in a month at a factory. So the number of accidents, you can count it. Then we have it to be what? Discrete random variable. So these are some kind of examples of random variables. All right. So now we're on section 4.2, probability distribution for discrete random variables. So now we are focusing on discrete random variables. We will talk about the continuous aspect of it in our next lecture or in chapter 5. So for now, for each value the random variable takes, you want to find the probability that it actually occurs. So you have the values of that random variable and the probability of it occurring. You put them in a table. This gives us what? The probability distribution for such a discrete random variable. Okay, these are two conditions for the discrete random variable to satisfy. One is that for each outcome the random variable gives, we want to find the probability to be between 0 and 1. And we sum all the probabilities for this random variable, the outcome of this random variable, then you should get what? 1. Okay, so if you're able to satisfy these two conditions, then it implies that we have a valid probability distribution for such a discrete random variable. Okay, so there is a question here or some example here for us to check the validity of the probability distribution of such a random variable. So we have the values of S, we have the values of that discrete random variable and the probabilities associated with each outcome of it. So first of all, we have to check that the probability of each outcome occurring should lie between 0 and 1, and that is satisfied. And 2, we also sum the probabilities and get 1. So yes, this is a valid probability mass function. That is probability distribution for that random variable. And we have to find what is the probability that a randomly selected family had 2 children. So we go to the 2 column and we check. So we go here, then we check, we realize that it's 0.3. Okay, 0.3. And what is the probability that a randomly selected family has at least 2 children? So that is probability of S greater or equal to what? 2. Probability of S greater or equal to 2. So we pick from 2 up to 5, you add them, or you can also use the approach that since the probability of S greater or equal to 2 could be written in complement rule as what? 1 minus what? Probability that S is what? Less than what? 2. So this is equal to 1 minus the probability that you have S to be equal to what? 0 plus the probability that you have S to be equal to 1, right? So we know this probability that is 1 minus what? 0.1. plus what 0.4. Okay, so you add this, you're going to get the same as 0.5. Okay, so this approach also works. Okay, so we have another example, but here you have two-sided six-sided fair dice. So each die has 6 outcomes on it, 1, 2, up to 6, and so 2 of them. And if you roll these dice together in all, you're going to get 36 outcomes. So we define the random variable to be the number that is higher when you roll these two numbers together. Okay, so this is how you construct the space, the sample space. So you're going to have 1 coming. So you have 1, 2, 3, 4, 5, 6 for the first die, and 1, 2, 3, 4, 5, 6 for the second die. You realize that this where the what we have 1, 1. So we do same for what this. So what this random variable is defined is that we want to find the 1 when these two dice occurs, which of them is what is the highest. Okay, so you realize that the possible values you could take is what 1, 2, 3, 4, 5, and what 6. So these will be the highest values there. When these two dice are being rolled, what will show will be what the highest. So the chance that we get 1 to be the highest is 1 out of what 36, and the chance that we get 2 to be the highest, we are going to have 1, 2, 2, 2, 1, and 2, 2. So realize that in these outcomes, we have 3 out of 36, and 3 is also happening 5 times. We apply the same, 6 happens 11 times, and so on and so forth. Okay, so this is how we calculate what these probabilities. Okay, so we want to calculate the probability that S is greater or equal to 5. So we pick from 5 to what 6. So that is 9 over 6 plus 11, 9 over 36 plus 11 over what 36. Then we get our result, that is 20 over what 36. And see, we have to calculate the probability that S is an even number. So you check we have probability that S equal to 2, 4, and what 6. All right, so you add these three together, then you're going to get the probability that S is an even number. Okay, so since this is a random variable, we want to find some kind of the location of this random variable in the long run. Okay, that the expected value of it, we call it the mean or what mu. All right, and we want to know how spread the data points or the outcomes for which this random variable gives, how spread they are. Okay, so we use the variance to measure that, and we can take what the standard deviation of that. Okay, so the mean of that random variable is giving us the sum of its possible outcomes times the probability of that outcome occurring. So we have the formula here, as you can see. All right, then the variance of that random variable is what you sum it over what S minus mu all squared times the probability of S, or is equal to S squared times the probability of S minus what mu what all squared. All right, so all of these actually works, but we are going to use a calculator way to actually apply it. But in case you have been asked to find the expected value or the mean of this random variable, you can state the formula and use your calculator to actually also get the value of it. Okay, so we're going to check some examples, right? So suppose a fair coin is tossed 3 times. So we toss this coin 3 times. Okay, we define S in the number of hairs. So we are focused on the number of hairs that actually occurs in these 3 tosses of a fair coin. So S. So our S, our sample space, will be what we are seeing now, or you can use the tree diagram to get a sample space. So that is what is here. Okay. And so now our focus is on number of hairs. You realize that within this, we could have S. If you define the random variable S on our sample space, the number of hairs we could see is 3, we have 2, we have 1, and what 0. Okay, and what is the chance that this actually occur? Okay, so we have for out of this, we have 8 outcomes in the sample space. So the probability that we get 0 hairs is 1 out of what? 8. That is just tail. So that would be tail because you have 0 hairs here. And if you get 1 head, it implies that we have this. 1 head will be this one. you're going to have this. No, yeah, this. And you're going to have this. So we have 3 out of 8. 2 heads will be, we have this, we have that, and we have what? This. That's also 3 over 8. 1. And 3 heads, you only have 1. So that is 1 over 8. So you can also verify that this is what a probability distribution of such a random variable. If you sum all of them lies within the ranges of what? 0 to 1. And if you sum them, you should get 8. So indeed, this is what a probability distribution for such a discrete random variable. All right. Okay, so you have to find the expected value. So when you go to your calculator, you just enter your when you go to your calculator, then you go to okay, sure. So you click on your stats, you will click on edit and enter the values. That is the possible values, the S states, and the frequency at what the L2. Okay, that's the probability. Then afterwards, you click on the start again. Then you click or go to calc. Then you choose one variable statistics. Then so we have our list to be the L1 where our S values, the possible values stays, and L2 will be the probabilities of these outcomes of our random variable. So we do calculate and we're going to get our expected value, our S bar. So our S bar is our expected value. And here we are going to use the sigma S, not the SS, not the S with S. We choose the sigma S. Okay. So the sigma S gives us what? The sigma S gives us our standard deviation. I put the sigma S gives our standard deviation. Then we take the square of that. Can take the square of that. Then we can take the square of that. Then that gives us what? That's going to give us our variance of that random variable. Okay, so this is how we use the calculator to get both the expected value and the variance. So if you ask about the variance, make sure you take the square of it. But if you ask about the standard deviation, then that's the value you see there. All right. So note how we use that, and we're going to apply it anytime you see mean. Just apply the formula or the approach that I've actually given to you. Okay. All right, so we have a probability distribution here, and we have to find the probability that S is greater or equal to 2, but less than 5. So it's greater or equal to 2 means that we pick from 2, 3, and 4. But since it's less than 5, we don't include the 5. So it's 2, 3, and what, 4. And what is the probability that these outcome actually occurs? So we have probability of S equal to 2 plus that of 3 plus that of what, 4. So you sum them, you get what we want. Then you can also punch this in using the calculator approach to get your expected value. And we have the standard deviation just as we just worked. And so I have the calculator approach being printed on this page, so you could verify your answers as well. Okay. So now we have another example, but here we have to find the probability that S is actually what? Greater than 2, but what? Less than what? 5. So we pick values that are greater than 2 and less than 5, and that is 3 and what? 4. So note it very well. The less or equal to really implies much. So if you have something like this, it's very crucial. Some things like this, and you have maybe A less or equal to S less or equal to B. These are very crucial in discrete random variable. But when you get to the continuous aspect, you realize that it's quite different. Okay, so these are very key. This is A. And so notice I've written some different aspect of it here. And I've noted the numbers by any, like, let me use A for here. Okay, so this means that A is included, and this means that both A and B is, this means that A is included as you move upward. This means that A and B are included, and you add their in-betweens. This means that only A is included, but B is not part. This means that only B is included, but A is not part. This means that both A and B are not part. Okay, so note it very well. Okay. Then we use our calculator to get our expected value and the mean. Okay, so by the example or how I've explained the inclusive and not inclusive, you can actually find the probability that S is greater than 0 but less than or equal to what? 4. So greater than 0, we pick from 1, 2, 3, and 4. Okay, so we add their probabilities together, then we get our answer. Okay, we do same. We can calculate the mean and the standard deviation using our calculator. Okay, there is an example here, interesting example. We are saying that in the New York State Numbers Lottery, you pay $1. Okay, so you buy a ticket, you pay $1 and can bet that the sum of the numbers that come up is 13. So if it comes up 13, you win. The probability of winning is what? Is 0.8. And if you win, you win $8, which is a profit of what? 7. This implies that you win 8, you paid in what? 1. But if you lose, it implies that you get no profit. So it's 0 minus 1. So that is a loss. So our S is our net gain. So it implies that our net gain is our profit. Our profit minus what we actually paid for. So we have, first of all, is 8 minus 1, we get 7. And we have 0 since we lose, you get $0 minus 1, and we get negative 1. So the possible values of S is 7 and minus 1. And the probability that we win is what? 0.08. That has been given in the question. And if you want to get, since we and the probability of losing is what? 1 minus 0.08, and that is what? 0.92. So there's a high chance that you lose. There's a high chance that you lose. By this, our expected value will be, we expect to actually lose, if we were to play the lottery many times in the long run, we would expect to lose 0.36. So the negative sign shows your loss. We expect to lose 0.3 for every one ticket you purchase. All right. So this is an interesting. So you have to find expected value. Expected value, you can use your calculator or you can just use the formula provided. So we have it here. And you're good to go. Okay. All right. So this actually tackles 4.1 and 4.2 about random variables and discrete and their probability distribution and probability distributions of these random variables. All right. So now we're moving on to the binomial distribution. Okay.